Hi, so we're going to start with logarithms and exponentials, and what we're starting with is exponential functions. Okay, so you should already be familiar with exponential functions, even if you don't know what they actually are, you have seen them before. Okay, so they're functions where we have y equals a to the power of x, and we call a is the base, and x is the exponent, which is where the exponential bit comes from. Okay, so if we graph this function, what happens is as long as a is greater than 1, we get a graph where we start really low, down, and then as we increase our value of x and becomes greater than 1, our graph greatly increases, so it goes up really high, and this is called exponential growth, because the graph is growing. And if you think about it, if we were going to put some numbers into our graph into here, we can pick any value of a, but if we think of, say, a is 2 to the x, so that's an exponential graph that we could, or an exponent that we could plot as a graph. If we pick that, we know if x equals 1, y equals 2. But when x equals 2, y then becomes 4. And when x equals 3, y becomes 8. When x equals 4, y becomes 16. And when x equals 5, y becomes 32. So you can see our graphs are like the values of x are increasing linearly, like 1 to 2 to 3 to 4, but our y values are getting increasingly larger, not at the same rate, and that's an exponential graph. One of the things we can use this for is to discuss kind of population growth and things. As we're growing, the population will double, and that's kind of what's happening with this. As you can see, every single step we're doubling our graph. That's what happens because it's 2. Okay. Another thing that we can get is what we call exponential decay, and that's where it starts really high, comes down and goes to like a 0 or something similar. And this happens when a is between 0 and 1. So that happens, but if a is greater than 1, then we get the black graph. Okay? So one of the things that's really important with exponentials is the introduction of the letter e. Right, so like I was saying, we get the letter e. And y equals e to the x is a really specific function, and it's used a lot in maths, and so you are going to see it a lot. And e is just a number. It is in fact a transcendental number, same as pi, but all that means is that it's a number that can't be expressed as a fraction. Okay, so e is approximately equal to 2.71828. Okay, and you can find e using, it's the limit as n reaches infinity of 1 plus 1 over n all to the power of n, but don't worry too much about that, okay? That's just where that number has come from. So it's kind of like pi, but there's no kind of, the equation for it isn't nearly as simple as the equation for pi, that it's just the ratio between the circumference and diameter. This time it's a bit more difficult. But if you put in big numbers into that formula there, so 1 plus 1 over n to the power of n, you will get that it'll approach 2.71828. Okay? Right, so we can use this in questions, and we will see it quite often in questions where we have growth or like things to do with bacteria and things. So I'll just do one quick example with e, and that'll be us for exponentials for now. Right, so let's go with the atmospheric pressure p to the power with a little h at h kilometers is given by p with that little h equals p naught e to the negative kh. Okay, so that's quite similar, it's quite common that you'll see formulas like that, and where p naught is the initial pressure, or the pressure at sea level for this case. But it is quite often that you'll have the initial and the current kind of pressure or values for your question. Okay, so we've been told that the pressure at sea level is 760 millimeters of mercury. You don't really need to understand that, it's to do with thermometers. And K is equal to minus 0.126. Okay, so calculate the pressure 3 meters above sea level. Right, so when it comes to these questions, I think the most difficult part is kind of, because it's quite wordy, is knowing where to start. So the place to start is always, firstly, to write down your initial equation. So that's kind of what we've got to work to. And then you write down what you've been given in your question. So the first thing we've been given, which is here, is that sea level is 760 millimeters of mercury. And P naught is our sea level pressure, so we know that P naught is 760 millimeters of mercury. We've been told here that K is equal to negative 0.126, and we've been told to calculate the pressure at 3 meters, so that's our H, our height. Okay, so we can now just substitute those values in, so we get 760 times e to the power of negative 0.126, and it's actually negative because there's k is negative and we've got negative k, so we kind of have two negatives cancelling each other out, times by 3, and then it's just a case of putting that into your calculator. On your calculator, if you have a Casio, your E button is E with a little box like this above it, and you get it by pressing Shift and then the button LN. It's just below log and just above tan. So that's how you get your E, and then into there you can put the values and you'll get 1109.115, and then you can say that's approximately 1109.1 millimeters of mercury. Apologies, pen's going haywire there for a second. And you can plot the graph if you wanted to see that that's actually what you would get, but that's working with exponentials.